you should expect always. How long do you have to do your homework? 2 days. So the other reason that I'm collecting tomorrow instead of Thursday is I won't be here Thursday afternoon. So for the morning class, if I want to collect their homework and see if they turn it in on time, I need to do it Wednesday. So yesterday's homework, 523, with 521 and 522 are due tomorrow.
So 521 through 523 are due tomorrow? No. Yes.
521 through 523 are due tomorrow.
Oh, okay.
So your plan book,
So this
if you go
one,
back
this
to
one,
yesterday.
and this one. So yesterday's homework.
Oh, go eat next to it. Maybe I shouldn't say because then people will bombard you. I did. Thank you very much.
Okay, so Thursday's homework, Friday's homework, and yesterday's homework are due tomorrow.
Yes, all Chapter 5 homework that you've had up till, but not including today. Notice the color change too. They're on purple now. So here's the easiest. The blue homework papers are due tomorrow. Here, we'll write it here. Blue due tomorrow. Right here. Blue due tomorrow. Blue due to tomorrow. Blue due to tomorrow. Orchid due Tuesday 21. Thank you.
So orchids have to do
These are your orchids there.
Can you say purple?
No, because orchid's more fun.
But that's what I have to write down in your plan.
I feel like a lot of you haven't drawn that number line on your graph paper because some of you don't have graph paper out yet, but yet there's a lot of side conversations. That's it. Thank you very much. So I'm confused at why we're talking when we're not ready to go. Once you're ready to go, then maybe we can chat. Like, how was your night? Mine was great. I got 3 new ropes on me at the rock wall. Oh, great. My morning is a little tumultuous, though. That's a nice $5 rope for you. They are currently ripping out the outdoor classroom.
No.
They'll put it back. Seriously, they're gonna put it back. But so that they have space to do construction and have their machines moving and everything. If they didn't rip it out, they would have destroyed it. So if you look at Mr. Cavillo's room, if he lets you pop the door open, which he may not because it's a construction zone, but the Gaga pit is just the posts. All the walls, they took all the walls off of it. So. Alright, do we have this number line drawn?
Yeah. I need a ruler.
Once you draw that number line, I need you to place 10 circles above numbers. Choose what numbers you like. You can put more than one circle above a number. Anybody care what we're doing?
Yeah, what are we doing? No.
We're going to roll 2 dice and add the total. We're going to roll 2 dice. Papers pass out still. I normally do. Do we still not have a Nikki? Still no Nikki? We have a Molly now, though. And a Callie.
And Olivia.
And Olivia.
And Olivia. And Olivia.
And Olivia. Alright, hurry up. 10 circles above numbers. 10 circles above numbers. Now, you are going to cross out circles while, or when, we get a result. So this is not one of the rules, but I'm trying to show you what we're about to do. So, if this is my roll, sorry, it's a little too bright. Maybe we should do this.
That's a really smart idea to fit in a little box.
A 3 and a 6, so that'd be 9. So you cross out a circle above 9 if you have any circles above 9. If you don't, well, you don't. You are putting 10 circles above your number line. You will cross them out if that number gets rolled. So you don't talk, don't talk, don't talk. You do. 10 circles, because you're not putting one above each. You're putting them wherever you want. All right. I'm doing one round. I'm doing one round before you know very much. So, I'm going. If you don't have your circles drawn, that's okay. But I'm going to go, and we're going to see what we end up crossing out. Somebody also just keep track of our results. So, like, write down the number that we get when we add them. So, here's roll number 1. A 3 and a 5. So that's an 8. Somebody write down an 8 for me, please. And then if you have a circle above 8, cross it out. Yeah. No. That was an example to show you guys what was going on. Cross out an 8 above, like a circle above 8 if you have it. Another 8. 5 and 3. Just the other way. Yeah, cross it if you have another circle above 8. So if you had 2 circles, you can. I told you. 7. A 4 and a 3. So you've had 8, 8, 7. 9. There's your 9. Another 8. Now, for those of you that might be like, wait a minute, is he somehow cheating or his dice weighted? Or can we really trust Mr. Hudson?
No.
I don't know if you can. So, here we go. 2 dice. There's a 9. Not even dice that I'm rolling. These are 2 6-sided number cubes, so we got another 9. Rolling again. Got another 8. Guys, I did not plan this, I promise you. My Scout's honor. Whole thing. Roll again. 11. There we go. Anyone have an 11 that we're crossing out?
Oh, I forgot 11.
Let's roll again. Roll again. 7. Roll again. We got a 2. We got a 2. Snake eyes. Roll again. 7. 7. We got a 7. We got a 7. We got a 7. 9. So at this point, especially since Bella just shouted something from the back room, draw another number line, but give yourself some space so that you can fit circles above it.
I lost count of the numbers.
Right, we're going to reset. We're going to try to use some strategic thinking here.
Okay.
So, Bella, why'd you just yell something from the back of the room? What do you mean? Tell me more.
Because there's 2 dice, the lowest amount you can get for each one is 1, and you can only get 2. 2 is the lowest number you can get.
So let's say you're actually going to play against your partner at the table here. And if you cross out 10 O's before they cross out 10 O's, you win. So what Bella's saying is, if I'm player 1, I'd be silly to put an O here.
Yeah.
Because when we're rolling 2 dice, I can't get a 1. Now, can I get a 12? Yeah. But which is more likely? A 12 or an 11? An 11, right? Arguably. Now that doesn't mean 11 will actually happen more times than 12, because remember we saw experimental doesn't always come out to match theoretical. So take a moment, don't talk. Place your 10 O's on your new number line where you think they would best, like, have a biggest chance of getting hit. Like that number has the biggest chance of getting rolled. 10. You get 10. There are the numbers from 1 to 12 on your number line. Yep, so number line looks like this, and you are placing dots. Now, if you've played Settlers of Catan before, that actually helps you here.
Oh, I see.
Yeah, if you're not a board game geek, you wouldn't understand. It's only for us cool kids. I do. Give me just a second. I'll grab it.
Let's play Monopoly.
Oh, that's cool. I want a Catan clock. Hey guys, the internet's really slow today, but Zach, the internet's really slow today, but you guys shouting out things that you know aren't going to happen isn't helpful to us having a class where we learn things, get done with what we need to, and we can all like have an enjoyable time. So shouting out, "Can we play blackjack?" is just exhibiting your immaturity that you're clinging onto from elementary school. I would invite you to let go of that immaturity of asking questions that you know the answer to and join us as mature 7th grade students. So, I'm going to show you that Catan board in a minute, but would you guys like me to roll the dice like my dice or the computer dice? Wow, you guys don't trust me. Okay, you got all your circles? I'm going to go, I don't know, here. And
Did you wave the computer dice?
I'm going to set up my circles like this. All right, here we go. Roll 1 is a 10. We got a 10. Roll 1's a 10. So I'm just going to actually remove my dots when I get it. Roll 2's an 11. If you have an 11, cross it out.
Wait, do we want to all of them?
No, just one.
See, you're new at me.
Hey, when you get to all 10 crossed out, let us know. Like 8. Got an 8. So I'm removing an 8. You're crossing out 1, 8. Next roll. 4. If you got a 4, cross it out. I'm going to remove my 4. Next roll. 4. You have another 4. Cross out another 4. Next roll. 1 and a 2. Ooh, a 3. If you got a 3, cross it out. Next roll. We got a 5 and a 1. We got 6. You got a 6, cross it out. Next roll is 11. You got an 11, cross it out, or another one, because I think we already had one of those. Next roll, 5 and 3. You got an 8. Next roll, 6 and 6. We got a 12. Next roll, 3 and 2. We got a 5. You got a 5, cross it out. Next roll, 4 and 2. 6. Cross it out. Guys, I only have 3 O's left. Anyone have less O's than me left? How many you got? You only have 2 left?
I have
2?
I have 3.
Next roll, 2 and 3. 5. I knew I should have put one of those 7s on 5. Next roll, 5 and 4. 9. Uh-oh. Put up how many O's you have left. Show me. I'm curious. Okay, we got 1, 1, 2 1s. All right, let's see who wins. 2 and 1, 3. That's a surprise. Next roll, 4 and 2. We got a 6. What do you have your O on? 7. Oh, we all need 7. Next roll, 7. So Savannah and Olivia are our winners. Now, hold on. So, do either of you want to talk to like what your strategy was? Obviously, like you can pass if you want, because like you won. So how'd you win? You put 1 on every single number except for 1 and 2. Okay, Savannah, what strategy do you use?
I actually accidentally did 11 dots.
Okay, so you made it harder for yourself.
And counted them. I did 3 through 12.
Just like you put a dot on each.
Yeah.
Interesting. So that's not actually what I thought you guys would say. So, can anyone who plays Catan? Gosh, the internet's slow today.
And band we tried band teacher tried to play this on his phone and it wasn't loading.
Yes. Oh, no. Sorry. I get absent language. Who knows how to play Catan? Nick, do you know? Nick, can you talk about the dots on Catan? And Sarah, Nick, can you tell them?
Oh yeah. Okay, so then the more dots, the better, and the more you want to be there. Cause like the more dots means the more ways you can make that number. And then, the best I think is like 8 or something like that. Oh.
When the internet doesn't work, go old school, right?
That's not very old school.
What, a document camera?
Yeah. It's not very old.
So, on the Catan game board, the numbers of the locations of where you can go have dots under them. Sarah, do you want to jump in and talk about those dots, like 2 versus 6, and how that...
Oh, yeah. So on some of the dots, you have like a more likely chance to get it, I guess.
How? What? Like, why do we have a more likely chance to get it?
Because you have 2 dice.
Okay.
And so, you basically want to place your settlement near like a higher number.
Yeah.
Number that has more likely chance.
More dots is better than less dots. It's harder to get a 3 than it is to get an 8. But wait, anyone notice anything missing from this game board? Yeah. A one, well, there's no 1 because you can't get 1. Nick?
7.
The 7. That's curious. Nick, what does the 7 do in Catan?
The 7 is the bandit, which is a real poop head.
What? Okay, so he's a poop head, but why?
Because he stops all your resources from coming in. But then the reason 7 is like the big poop head is because 7 is the most common number to get with 2 dice.
Why?
Because like you. So then you have more ways to make 7, like 5 and 2, 3 and 4.
Ah, the ways we can make it. Please, on your graph paper, write down probability table. I should see every pencil moving. I'm not doing this. A probability table shows all outcomes or results, if you like that word better, but I like outcomes. Shows all outcomes of 2 events. Now the problem of why it's 2 and not 3, you could make a 3 event probability table, but it would actually be 3 dimensions. It wouldn't be flat on paper, it would actually be 3D. So when we talk about the 2 events that we're going to do here, they're both the same event, but we do it twice. To be efficient, we just have 2 of them. So if we think about 2 dice, and here's something that I really wish board games would have done from a long time ago, think of them as being 2 different things, like a red die and a green die, or a clear die and a white die, right? So think about the fact that a 1 and a 6, like Nick was talking about making 7, a 1 and a 6 is not the same as a 6 and a 1. And what's fun is since every die is made the same, you can actually, like, once you make matches, you can flip and find. So 5 and 2, 5 and 2, right, if I just flip them. But this is not the same as this, right? And sorry, you can see through this, so it kind of messes with your eyes. But that's a 2 on this side. So I'm going to color code this. And one of my dies will be white, since I'm already writing in white. So we're going to make a table. Make a square on your paper, but what you're going to fit in that square is all outcomes of the dice roll. So make it big. I know. Because then I'm going to do this.
Oh.
I love you guys.
Should I do a 6 by 6?
Why do you teach middle school? Because they tell you when you tried to make a square and all you made was a line.
Should I make a 6x6?
Yes, essentially, we're making a 6x6, but I would not limit it to the size of your graph squares because you don't want to write that small. But if you do want to write that small, I guess that's up to you.
I'll do a 12x12.
Wow, you're going up and down. A D30.
Yeah, so if we were to make this table with something like D30, it would very quickly get very big.
Yeah.
And then split your table up, please. And then I'm going to write the results. And now let's go purple. So fill in your table with the results. You shouldn't really need me. But a 1 and a 1 make a 2. a 2 and a 1 make a 3.
You should be a math teacher.
You know, I thought about it. I don't think I want to work with kids though. I just don't like kids.
Yeah, that kind of sucks.
Yeah, kids suck.
They're like no fun at all.
Yeah, I know.
All they do is want to play blackjack.
And most of them don't even know how to play blackjack. They just think they want to play blackjack.
I wouldn't work with kids, you know.
So you gotta teach us. Yeah, you have to teach
Yeah.
us. You're
You gotta
teaching
just
us.
gamble.
We gotta teach us to count cards.
Are you filling in your table?
Count cards,
Blackjack.
I like kids. You gotta count cards, man.
Yeah, I wouldn't be.
Teach us real
I'm not supposed to count. I gotta count cards.
Guys, we're gonna use this table a decent amount. At least like the thought of this table. So make it decent so you can refer back to it. Because you're gonna be asked, and actually probably like on a mastery, which hey, you know it's been a while since we've had an open notes mastery. It might be about time. You're gonna be asked what's the probability of rolling a 7 versus what's the probability of rolling a 12. So Nick, to come back to this poop head,
Yeah.
you said the roll of the 7 activates what you called the bandit, but he's actually called the robber. So here, 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 here. It is kind of like your schedule.
Bingo.
Yeah, because we got the best one where it just goes.
Yeah, depending on your letter group. So, Nick, if we talk about the chance of the poop head happening, the bandit, or whatever we're going to call them, we would talk about the probability of 7. So please on your paper write down P of 7, probability of 7. I'm going to clean this up a tiny bit, a lot of it. How many 7s are there? 1, 2, 3, 6. How many total boxes are there in our 6x6 table? 36, right? So this is 6 out of 36, or a 1/6 chance.
Would you gamble on your odds of getting a 7?
I mean, it's the most likely dice roll, so if I had to gamble,
Game where you like roll dice and you bet on like what dice number you
yeah, it's called craps.
You're really into gambling, aren't you?
How many 8s are there?
8, 5.
5, right? 1, 2, 3, 4, 5. We can count on the table. Out of 36. And here is where I start to really flex that there is a connection. Come on, you're really not long enough.
Did you take your hard pill?
I did. Thank you very much. What's funny is you're like the 5th person to ask. Guys, look at this. The 8 here has how many dots?
Oh, we can I can't see.
I got like 4.
5. How many dots does the 5 have? 4. Let's calculate what the probability of a 5 is.
I see what they're doing.
What are they doing, Savannah?
Does the board have 36 spots?
It's not that the board has 36 spots,
They're
but
doing the probability of landing on
Yeah, they're giving you the numerator. Guys, Catan, one of my favorite games, is giving you the numerator of the probability. The probability of 11 is 2 out of 36. The probability of 9 is 4 out of 36. The probability of 12 is 1 out of 36, right? Because there's 1/12. So when we talk about the probability of 12, it is literally 1 out of 36. It's very hard to happen. That's about 3%, not even. That's 2 point something percent. But it can happen. It doesn't mean it won't happen. It just means it's pretty rare. Now, Heartbreak, though, the new version of Catan, the new boxes, the new game pieces, don't have the dots. Now, what they did with the new game, actually, I'm thinking about writing the game company and saying, like, dude, bring back the dots. What they did now instead, they kind of showed on the back of this box, they made the numbers bigger or smaller. Actually, they might still have the dots. They just made the numbers bigger and smaller. Because I think this is the new box. Yeah, so you can see the dots on the game pieces, and this, I flipped this box, and now it's all over the place. But this is where the probability is shown to you. How many dots it has tells you. And guys, there's no 7s, because 7 is the most likely occurrence, right? So they want the thing that happens most to not pay somebody resources, because that's not really fair. They have it completely shift the game for them. Like, in that moment, when a 7 rolls, everything changes, right? The robber moves what spot he's on, and the robber actually blocks people from being able to take that resource. As Nick said, now this is where things are misunderstood. The robber doesn't steal the resources, he just blocks them. But, so, if we think back to our number cube game, Gerald listed out all of the results like this, but we're a tad bit smarter than Gerald, because you have a teacher that didn't want to waste time with having you guys list things like this. Apparently. So, it's like, hey, as I think you guys know, I like you, right? Big surprise, I like you guys. So in the lesson, we could have done this and said, okay, cube 1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, like, we could do all these options. But do you see how this is a much more efficient way to look at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and all of the possible outcomes?
Yep.
So I didn't want to have you waste time like this, so we're going to skip on beyond that. But this is a way we could look at this. When I have a 1 and a 1, or a 1 and a 2, or a 1 and a 3, or a 1 and a 4. Like, it's just annoying. So Gerald finally got a teacher like me that said, hey dude, organize your data a little bit better. And guys, also, I'm going to make this request for at least like the next 10 minutes. I'm hoping that the afternoon class can use the video that I'm taking right now to just be their lesson, since I won't be here. So if you guys could try to not have the side conversations. I should have said that at the beginning. So that's why I'm just kind of trying to like breeze through this stuff and show everything to make sure that they understand all of that. So when we have this all filled in, we can see there's no chance of a 1 in the table, right? Because these are the results. And we saw the 7s go straight down this middle, kind of like your guys' schedule. And the 12 live down here by itself, all alone and rare to happen. So when we look at that table, we can actually look at things that are equally likely, right? So we just looked at 5 and 8, which aren't equal, but what would be equal to 5 if we come down to the other side of the table? The 9, right? If we're looking for what's equal to 5, the 9 also has 4, just like 5 had 4. Sorry, got a little offline there. So 4 5s, 4 9s, they're equal probability. So 2 has the same probability as 12. 3 has the same probability as exactly. Does that make sense? Yeah, and as some of you are moving on, 10 and 4 have the same probabilities. 7 is its own because it has the greatest probability and has no other match. That's also why Catan designed that game like that. It's not fair because nobody else matches it. So, Gloria and Jenny now, right? They're playing tenos. They each, just like Savannah and Olivia, have 1 O left.
Oh no!
Now, let's just forget about Gloria and Jenny. Let's say Olivia has her O on 6, and Savannah has her O on 8. Who is most likely to win?
They're equal chances. Oh, sorry.
Can you cut your hands off?
Yeah.
Savannah, especially since I just used. Well, actually, I'm going to jump to Toby because you already talked about this earlier. Toby,
Equal chances.
why?
Well, because they each have 1 left. And
What?
they also, oh wait, hold on.
Do the dice rolls that have already happened impact the next dice roll?
No.
No. So these are.
There's no chance of
Are they
them-
independent or dependent? Independent, right? Dice rolls are independent, and one die does not impact the other die, right? What's the probability of 6? Look at your table. How many 6s did we have?
5.
Ooh, somebody said 4. 5 out of 36. How many 8s do we have? 5 out of 36. So
Oh, right. Coincidence.
arguably, neither of them is going to win.
It's a tie.
Or like, now one of them will win at some point. But if Toby is like, wait a minute, I wasn't paying attention for a minute. I only have 1 circle left. I only have 1 O left. It's on a 7.
Oh, he wins.
Toby's most likely going to win. But that's theoretical. Remember, that is theoretical. Experimental might come out different. Questions? So, let's go back to yesterday's content that we were talking about.
That's so good.
Rock, paper, scissors. Right? This is 2 events. Sorry, I thought I was still on the highlighter. Rock, paper, scissors. So let's make a probability table for rock, paper, scissors. Right? So across the top, let's do RPS. And then across the left, RPS. Yeah, so in the middle where we put the results, just write out your results, then we'll go back and indicate who wins. As they used to say on Salute Your Shorts, a tie is like kissing your sister, so I'm going to circle those in red.
Ew!
I know, ties are gross. Nobody wants to tie. So those are our ties, right? Rock, rock, paper, paper, scissors, scissors. Rock, lobster. I'm going to circle in blue when blue wins. So rock versus scissors wins. Paper versus rock wins. And scissors versus paper wins, right? When blue throws scissors and white throws paper. And then the probability of white winning, well, when white throws paper and blue throws rock, when white throws scissors and blue throws paper, or when white throws rock and blue throws scissors.
Oh, I get that.
So when we talked about this yesterday, we said, well, hypothetically, it seems like got a 1/3, 1/3, 1/3. If we look here, let's say we are white. What's our chance at winning? Well, 3 out of 9, which reduces to 1/3, right? So if we say our chance at winning, according to this table, is 3 out of 9, say it's 1/3. So our chance of not losing but not winning is 2/3. Our chance of losing is chance of not winning is the complement. It'd be the 2/3. But then my chance of losing is actually 1/3. And what's blue's chance of winning? 1/3. So is rock, paper, scissors fair? Yes, up until somebody anticipates, right? If you get to learn your opponent, if your opponent is weak enough to be learned, right? I guess we'll say that. Then it's not really fair because yes, that's why you use your poker face. Poker face. Hold on. You didn't think it was just gonna be that easy, did you? Oh, hey, hi, I have 5 minutes left. Actually, more than that. So, we're going to do another, because you couldn't have thought it was just going to be that easy. We have a bag with some blocks in it. Of course, we all, you have bags of blocks at home, of course. We've got a red block. We've got well, that's not able to be red. A blue block. And a green block. And a yellow block.
Wow, so many blocks. 4 blocks. In a bag?
Is this, hopefully you read the rest of the sentence, is this independent or dependent? Callie, what do you think? Why? You're right, but I want to make sure it's not just a guess. What do we do that makes this situation independent instead? Because this could be dependent depending on how we do it. There's one big word up here. We replace. So guys, what I'm going to keep trying to drive home to you is when we replace, we reset. Right? When you put the block that you drew back in the bag, you reset the situation and it becomes independent. If you don't reset, then it's dependent. Okay, so this is independent. So we are independent here because we replace. These are the connecting thing that makes that happen. Yes, it matters if we replace the block because that changes our probability. Now here's where this gets funky. And I'm not going to color code because it's too hard. We have red, blue, green, yellow, right? Yeah. So red, blue, green, yellow. Yes, we're going to make another table. Oh boy. Who knows who that is?
Your mom.
No. Wow.
Obviously it's Mickey. You guys were saying, oh boy. So I decided to join. And then write the color results, right? So red, red, or red, blue, or red, green, which is actually an old Canadian TV show, or red, yellow. Has anybody in here seen red, green? I will be surprised. Okay. Maybe I'll show you guys a clip at some point. It's really funny. They fix everything with duct tape.
What?
Yes. Crap, that's green, red.
You watch Canadian TV?
Oh, it's so good. What you talking about, eh?
You're Canadian.
Wait, do you watch it on like YouTube?
You have no proof of that, eh?
Mr. Hudson's actually a canary piloting a human body.
A canary?
Yes.
Oh.
It's very warm in here. In this body.
How do
What
you
was the, was it Men in Black 1 that had the alien driving the human
I think so.
inside of them? You guys probably weren't even alive when Men in Black 1 came out.
I watched it though.
So find the probability of getting a red block and a blue block. Do they care which draw we get which on?
No.
No, either can come first. So red and blue block. Okay, we're looking for red, blue, and blue, red. Because red, blue, and blue, red are two different things. Right, so my probability of getting red, blue, or blue, red is, got somebody else, is what, Bella? What's my probability of getting a red and blue combination? Doesn't matter which is first. Yeah, 2 out of, and then how'd you find your denominator? Yeah, a 4 by 4 table gives me 16 total options. So really we could reduce that to a probability of 1/8 if we want. Or 2/16 is just fine. Any questions on this? How we use that table? Now, where we're heading with this is what if we do this same situation, but I tell you, don't do this, okay, but where we're heading. But I tell you there's 1 red, 2 blues, 4 greens, and 7 yellows, or something like that. And our probability starts to change. So each of these squares won't be equal, and we'll actually be putting the probabilities inside those boxes. But that's not what we're doing today. That's where we're heading. Okay, that's like the next thing that we do. So, hold up. Just review before we get out of here. What we started talking about yesterday, compound events. Meaning one event and then another event. Right? So, we can have independent or dependent depending on do we reset the situation. So, you can check this out. It's in your ebook or it's like right here, obviously in the video. When we're talking about king or queen, they bring up this situation that we didn't talk about yet, so eyes up here would be a good thing. If we have an or probability situation, they don't care if they get a king or a queen. So what we would probably be tempted to do, which would work fine, is just add the kings and queens. How many kings and queens are there total? 8. The other thing you could do is figure out each probability and add their probabilities together. So a note you want to make that later I'll need you to actually memorize is or tells us to add. Or tells us to add, which is tough because we're used to and meaning add, right? In probability, or tells us to add. Have a wonderful day, guys. Yeah.